Okay, hey everybody. I already apologize in advance. It might be that my router will crash. It had kind of trouble keeping up the connection, but it seems stable for now. So I try to stream. Like I said, maybe it's choppy, maybe it dies completely, but we'll see. Um, okay, so what are we doing today? So technically, this stream is just an addendum to the one I did last time, which had the same title card because I was lazy. I couldn't be bothered to draw a new one. But essentially, what we did last time was we created a PCB for my VCO. Now this is the PCB for my filter. And of course, I haven't sent the VCO one out, but yeah, we made a PCB like this one for our filter, and as you can probably tell, this is not this is not a panel. This is the PCB where the components go on, and so the plan actually was last time that we would also make a panel. But we couldn't, I didn't have the time. In the end, it took so long that I was too tired to go on. So I kind of put it off to a future date, which is today. And so today we are going to make a panel, again, like this one. This is the panel for my filter. And we're going to make one for the oscillator we made last time. And I see someone in the chat is asking how thick it is. I think these are like the standard 1.6 millimeters. Like at first when I ordered these, I was a bit concerned that they might not be thick enough, but they're actually really sturdy. Like they're much more sturdy than I anticipated. So actually no complaints there. So yeah, I mean, of course you could always go thicker and then have a bit more sturdiness, but for me this is really okay. Okay. One more thing to maybe note here. So this strategy is kind of, I wouldn't say it's unorthodox. It's just that, normally when you buy a module, your front plate is most likely made from like aluminum or some form of metal. But yeah, I mean, in this case, I chose to go with PCB. And now the question is why? And the answer is very simple. It's because of cost, and because of kind of what's the word? No, not comfort. I forgot what the word is. I'm sorry. It's just easier because what you can do is if you create your panel as a PCB, then you can just order it together with your main PCB. And it arrives at the same time. It's super cheap. I mean, making these, I don't know, like I think with shipping, like for one module for these two things, I think I paid like €5, and the shipping was from China. So it's really it's absurd. Yeah, the word is convenient. The word is convenient. Yes. So for me, it's just really convenient to do it this way. And in the filter video, I already explained that there are of course some drawbacks. And I would say that the main drawback for me is actually that the print job is not perfect. So you can see here, like this is one of the panels that I haven't used because there are some kind of smudged up parts, and also of course the if you get up real close, you can see that the lines are a bit uneven, and especially like for the labels, it's a bit it's not perfect. But I think from a distance, it's fine. And also like always keeping in mind how cheap it is. I think it's a perfectly good kind of compromise to make, especially in the beginning, like if you're just starting out. Because if you want to get like actual like metal panels made, you're going to pay a lot more money, like especially if you don't buy a lot of them. Like with these PCBs, you can just buy 5 and they're not going to break the bank. But if you go to a manufacturer that makes like proper metal panels and prints on them and everything, then it's going to be more. Maybe it works now. I'm very very unsure. Yeah, it's super strange with the router. So it basically just like resets, reboots, whatever, and then it doesn't have connection. And I disconnected, I reconnected, it boots up, it gets a connection, but then you know, it's a gamble if it stays that way or not. So for now it seems to be okay. So let's hope that this keeps going. Okay, cool. Hi everyone who's new. Again, we are making a panel for my VCO, and I was just explaining that last time we built this lovely little PCB that has all the kind of circuit components on the backside, and then on the front we have our interfacing elements, which in this case they are actually quite limited. So we only have a potentiometer, which is the tuning knob, and then we have these two little jack sockets down here. So the one on the left is going to be the CV input, and the one on the right is going to be the oscillator output, the sound output, basically. And one thing that I went ahead and already kind of adjusted ahead of this stream is that I mean, last time placing the potentiometer and the jack sockets, I kind of just eyeballed it. So I just kind of tried to fit them or put the potentiometer in the middle of the PCB, and I tried to have like an even spacing down here with the jack sockets. But again, I just eyeballed it, and that's never a good idea in the end if you want to have something that looks consistent. So one tip, if you are doing this, it's a good idea to select these, like select your interfacing elements basically, whoops, don't move them, select them, and then here in the sidebar you have these two fields that are labeled X location and Y location. And so before, like as I said again, I was just eyeballing it. So before it was like set to some odd value like this, and it was like some weird thing here. And the problem with this is that it's just, you know, annoying for when you're then building the panel. So what I did is I went in here and I just rounded them up basically. So I said this is basically 20, this is basically 15. Oops. No, it's minus 15. Sorry. Boom. Okay, and then obviously what you have to do is, since we're using the copper area on the PCB, you have to rebuild the copper area so that these connections here to this copper area are kind of redone. Because I don't know if you saw, but there was like a little X in here, which always shows you that there's a connection there that doesn't work quite well. Yeah, and that's what I did. So I went ahead, I took the potentiometer, and I rounded up the location numbers. I went here to the sockets. I did the same thing. You can see that the values are nice and round. So we have 30 millimeters on the x-axis here, and minus 90 on the y-axis. And then here we have 10 and minus 90. So now they're nicely lined up. And this will just make it much easier for us to kind of design the panel, like, you know, just having even values. So that's what I did there. But apart from that, I did not change anything about this PCB. And so we can just jump right ahead and do the panel. Now, the first kind of question that we have to answer here is we have to know exactly what the dimensions of our PCB are. And there is a reason for that, which I will show you now. Okay, so again, looking at my filter module. So you can clearly see that the panel is taller than the actual PCB, right? And the question is, why is that? And the answer is very simple. When you assemble the module, so when you assemble the PCB to the panel, you need to have some space here simply because you have the mounting holes here, and you're going to have screws that will go through here, and they will mount to your case, whatever that is. And so you just need the space here so that you are able to properly mount your module into the case, basically. Now, I think we can also look it up on the Dupfer. You know, Dupfer has like this page that is dedicated to Eurorack specifications. So that there, I think they also specify the stuff. But in this case, I think what I did is, I don't even know if this is like 1 centimeter. Maybe it's a bit less, something like that, or it's 1 centimeter. But yeah, this worked. So we know that you know, if we do a panel that is 1 centimeter longer at both sides, then it will work. Okay, but to plan this, we will first have to kind of check out what the dimensions of our oscillator PCB actually are, because they're not identical to this. I think I made the oscillator a bit shorter. So let's look that up first. Let me switch over here. Okay. Now the question is, how can we do that? Well, actually we set it ourselves last time, and so we can use the same tool to kind of check up on how big this actually is. And the way you do this is you go into the tools drop down up here, and then you select the set board outline option. And this is the window that the program shows you when you are actually creating a new PCB. So it will prompt you to select the dimensions. And here we can see that we went for a width of 40 millimeters, which is roughly 8 HP. And we went for a height of 100 millimeters. So now the question is, what are the specifications for the panels, because those are fixed. And the way that we can find this out is not by using the search, but instead going here and then looking for Dupfer A100 construction. Whoops, like that. We go in here, and here we have this lovely page that has basically all the information that we need. So again, what I just said is our PCB is 40 millimeters wide, and that roughly translates to 8 HP. So it's actually a bit slimmer than the full 8 HP. But I think it's just a good idea to leave a little bit of wiggle room, you know, just to make sure that the modules fit next to each other. So that's why I went with 40 millimeters here. Okay, but this is okay, like this works. Now the question is, what about the height? So we just saw, like here in the program, we saw that our PCB is 100 millimeters tall. And here we can see that a panel should have a height of 128.5 millimeters. And so knowing that our PCB is 100 millimeters, we know that we have 28.5 millimeters to kind of to spare, like at the top and at the bottom end. And so what we will have to do, let me make this more clear. Okay, so live drawing session. It's also something new. What we'll have to do is, so let's say that we have our PCB. I'm not going to draw it like true to size, but I'm just going to draw it on here. So let's say that it is this wide, and let's say that it is, it's not true to proportion, but whatever. Okay, it's this tall. Boom. Let me draw this as well. Okay, so what we know is that we have 40 millimeters here and here. And now you see how ugly my drawings are when I don't have hours to perfect them, but yeah. So we have 40 millimeters in width, and we have 100 millimeters in height, like that. Okay, and then for the panel, I think what I will do is I will keep the same width, simply because, again, then we have like this, what was it, 0.15 millimeters on each side, kind of wiggle room to the next module. I think that's okay. If you want to be like really on point, you can also make your panel, 40.3 millimeters wide, but I'm just going to go with 40 here. So that's the same, but then what we have is we know that our panel is taller, right, than this thing. And we know that we need to leave space at the top and at the bottom, simply for the rails, like for the space where we will mount the module in the end. Okay. And now I think the most intuitive thing to do is to leave an equal amount of space at the top and at the bottom. And so we know that we have 128.5 millimeters in total in height. And our PCB here is 100 millimeters high. And so we learned that all in school. If we subtract that, then we get 28.5 millimeters, which we have to spare. And if we want to have equal space at the top and at the bottom, then we basically divide this by 2, and we get 14.25 millimeters at the top and at the bottom, which again, I think is actually more than what I have here. So it should be plenty of space to do the mounting stuff. So what we will do here then is we will make a panel that has these dimensions. Wait, 1, 2, 3, 4. 1, 2, 3, 4. Boom. Okay. And this is going to be important again soon. But for now, let's switch over to, to EasyEDA again. Boom. Okay. And I'm actually amazed that my connection is stable. So knock on wood, I guess. Okay. So going back here, we can now say that we want to create a new PCB. Now, what I like to do, and what I think makes sense, is to just create it within the same project. So we are going to click right on this folder, and we are going to say new PCB. And then, like I said, like the first thing that the software asks of you is to give it the dimensions of the PCB that you want to create. And these options are all fine. So we're doing it in millimeters. 2 copper layers, fine. We're going to do it rectangular, not circular, of course. And then we will have to enter the dimensions. So this time, I think I will again start at 0, 0. So, X starts at 0, Y starts at 0. And okay, so we know that our panel is supposed to be 40 millimeters wide. That is easy. And the height is going to be 128.5 millimeters. Okay, boom, easy. Zoom out a bit. And here we have our beautiful 8 HP module, basically. Okay, so this is already great, but there's nothing on it. So what we will have to do, wait, let me save this first. And let me give it a proper name. So we will call it, here we can. Let's call it panel basic shapes. So it's distinguished from the PCB basic shapes. Okay, so now we have the outline. So we have the dimensions right, which is already a good thing. But now the next thing is that we will have to talk about the holes that we have to drill for our control elements. And actually we have to drill more holes. So we have to drill a hole for the tuning potentiometer. We have to drill 2 holes for our jack sockets. And we also have to drill 4 holes for our mounting screws. Though I don't know if at 8 HP you might also get away with just 2 mounting screws. But I think I'm just going to go with 4 just to be thorough. So if you do this, feel free to maybe just use 2. I think it might also work. Maybe you can hash it out in the chat if someone has an idea, if 2 would be enough. But yeah, okay, so now when we want to drill holes, the first question is probably going to be how do we mark spots to be interpreted as holes by the manufacturer? And that's actually very easy. So we use this little menu here, PCB tools. And what we have here is somewhere we have hole right here. This thing is called hole, and if you click on it, then you can place a hole basically anywhere on the PCB. And of course, what I could do now is I could simply go ahead and I could put it here and pretend that now everything is sorted out, but of course it isn't, because we have 2 problems. The first problem is, how big is the hole supposed to be? Like we know that we are going to use a certain kind of potentiometer, but right now the diameter is just set to what? To 2 millimeters, and I really doubt that that's the correct size. And then also the placement is kind of questionable, because right now you can see the x coordinate is 20 millimeters, the y coordinate is minus 20 millimeters. And now you might say, okay, why don't we just go over to our PCB? Why don't we select the potentiometer, and why don't we just copy the values that we have in here? Problem is that's not going to work, simply because as we just established, this PCB is a whole other size than our panel. So again, this PCB is 100 millimeters tall, while this is 128.5 millimeters tall, and they both start at 0, 0 in the coordinate system. You can see that here too, right? Boom. So that's also 0, 0. So we can't simply reuse these values here. So now that there are basically multiple strategies to kind of combat this, I guess. So what we could do theoretically is we could just simply take our outline here, and instead of placing it at 0, 0, we could just push it up a bit. So let's say that we no, better. We will go with the set board outline tool. So what we could do is, instead of letting it start at 0 on the y-axis, we could actually just take the value that we just calculated here, which is 14.25 millimeters, and we go in here and we basically just say minus 14.25 millimeters. Okay, and now we can see that the board is starting. That's not correct. Okay, so what we actually have to do is we have to go up, right? So I just went down. I just went down from 0 to minus 14.25, but we actually have to go up. Okay, boom. And now what happens is that the other PCB, so the main PCB, is basically starting at this line, right? So this is 0 on the vertical scale. And our panel is now basically extending beyond that for exactly the 14.25 millimeters. So now we can actually really just take the values here. So if we now take minus 15, then it is not 15 millimeters from the top, but instead it is 15 millimeters plus 14.25 millimeters. So now the math actually checks out again. So we select this thing, and let me check again. So the X location is 20. So the X is 20. Oh, that was actually quite close. And the Y is minus 15. Okay, and as we can see, the hole is definitely further away from the top than it is here for this one, simply because we moved the outline up, and now the math checks out again, which, by the way, is something that I did not do before. Like before, I just calculated the values manually, but I just had this idea, and I'm pretty sure this would work, and it's much easier than what I did before. So good thing there. Okay, so first question has basically been answered. And now the second question is, how big is this hole supposed to be? So, because right now it's 2 millimeters, and the potentiometers that we use, they are definitely not 2 millimeters wide at the shaft. So I can show you. So last time we decided that we wanted to work with these alpha pots, which are quite ubiquitous in the DIY scene, in the DIY synthesizer scene. And that's simply because I think you can just mount them straight onto the PCB. And they are vertical, so they're looking up, and the connectors are going directly down. And so you can just solder that in, and they are looking up, and then you just add in the panel on top, and you have your module. You don't have to wire anything, and they just fit in. It's actually really, really nice. The only bad thing about this is that they are very sought after, and I think the company that makes them, they had like some kind of fire at the factory, and I think at the moment it's hard to get these. There's a shortage, but if you look hard enough, you can find these. But anyway, yeah. We decided to use these. Now, the problem is that, as you can see, this, how do you call this, shaft is not 2 millimeters wide. But I also don't want to just bust out like a ruler and measure it, because that's also error prone. So instead, what we should do is we should try to look at the datasheet for this thing to find out what the actual proper value is. So what I always do is I just go to Google, and I just type in the name of the part, which in this case is called, like the company that are making them is called Alpha, and they are simply called 9mm pots or potentiometer, and then let's put in datasheet, and let's see what we come up with. Okay, so you can already see that if we go to pictures, that there are kind of promising results, but there is an issue which I'm always facing when I'm looking at datasheets for potentiometers. Oh yeah, you can't see my cursor, right? So let me highlight this. Boom. Yeah, okay. No, I can't zoom. But yeah, on the left side, you can see the potentiometer from the side, and you can see a bunch of measurements there, which are all not that interesting for us. Oh, also these are the wrong kind. These are right angle. We need the vertical ones. So let's go to the vertical pots. Boom. Okay, so these are the correct ones. Even though I don't think it makes a difference for the shaft, but yeah, whatever. Okay. So down here, again, on the left side, you can see a bunch of information that is not all that useful for us. You can see something down here. I don't know if you can read this, but here it says that the shaft itself is 6.35 millimeters thick, basically. But the problem is that this is actually not the information that we're looking for, because you can see this here in the illustration. The pot is actually a bit wider at the bottom, you know, where the actual thread is. That is actually the value that we're looking for here. And the problem is that like all the other things are kind of labeled with the actual values, but here they decide to be cryptic and say M7X 0.75. Now this was very confusing to me when I was first working on my filter, so I had to look this up, and apparently it just means that the threaded bit is 7 millimeters thick. I don't know why they choose to put it this way, but that's apparently what it means. And so now we know that the threaded bit itself is 7 millimeters wide, but we shouldn't make the hole just 7 millimeters because we need a bit more wiggle room. And so what we should do is, oh, whoops, that was the wrong action. Let's go back in here, go back to EasyEDA. So let's select our hole here. And like I said, we should not make it just 7 millimeters wide, but instead we should give it a bit of wiggle room. So what I did was I went with 7.2, so we're on the safe side and we don't have to force the potentiometer through the panel. So that's what I went with. Okay, and you can already see that it's a lot bigger. But yeah, so now we have our potentiometer hole, which is great. Then the next thing is that we want to place the holes for our jack sockets. So like I said, we have 2 of them, so let's eyeball it, put them here and here. And then what we will do is, again, we will look at the values that we have dialed in here. So for the first one, we can see that the X location is 10, the Y location is -90. And since we already mentioned it, right, we can just use these values. So 10 and -90. Boom. And for the other one, it is 30 and -90. Okay, let's switch over here. We select this guy and we say 10, no, it was 30, right? 30 and -90. -90. Boom. Okay, that looks very good, but again, these holes are definitely too small. So again, off we go to Google, and what we have to look for is these are called, or commonly they're referred to as thonkicons in the DIY scene. Oh, whoops. And we will look at the datasheet again. And it leads us straight to thonk, and here we can see that can we actually see something? These are so hard to read. Ah, no, it's actually easy. Okay, so here we can clearly see that the threaded bit is 6 millimeters in diameter, and yeah, here is a kind of what's it called, like a cautionary warning. So you have to have a hole beneath the jack socket on your PCB, but as far as I can tell, I think it's included in this one. Maybe it's not, maybe we have to add it later. Oh, actually, you can just look at the 3D view. Okay, so we can see that in this footprint that I used, they haven't included the hole and that's supposed to go into the PCB. So that's we will have to do that too. So we have to put holes in the main circuit PCB here too. But we'll just sideline this for now. Just keep it in mind. So we'll jump over here, and again, looking at the datasheet, we can see that the threaded bit is 6 millimeters in diameter, and so what I would again say is that we simply go with a 6.2 millimeter hole here. Let me check that. Ah, yeah, okay, true. So simple, we select these, we say 6 millimeters on this one, we say 6 millimeters on this one, and boom, looking nice. Okay. And now the last part that we have to figure out is the mounting holes for the screws. And for that, we should go back to the Dupfer page because that should have the information that we need. Okay, so we can see here, that's very convenient. It says that the diameter for the screw holes should be 3.2 millimeters, which is it's because the screws that they use are actually 3 millimeters in diameter, so they also go with the extra 0.2 millimeters, you know, for wiggling room basically. Okay, so we know that it's 3.2. But then the next question is, how far does it have to be kind of away from the side? And yeah, we can see down here. So it's supposed to be 7.5 millimeters to the right. And, you know, looking from the bottom, it's supposed to be 3 millimeters from the bottom. Now, this is going to be a little bit tricky. If we do the bottom, but maybe first we do the top. So for the top, it's the same, so 7.5 to the right and 3 from the top down. So if we go in here, we put in a hole, and then we select it, and first we do the diameter, which is 3.2. We do the X center, which was 7.5, am I right? Let's check it. Yes, 7.5 on the x-axis, and then a 3 down basically. So we have to be at. Oh, this is tricky now because we can't simply go -3 because this is obviously too far down. Because again, our panel is not starting at 0, 0, but instead it's starting at 0 and -14.25. So now we have to do some math. So we have to go 14.25 minus 3 is 11.25. So boom. That looks very close to the top, but I think it's correct this way. If I look at my filter panel here, you can see that the mounting screws are very, very close to the top, so this seems to be accurate because this one works. I've verified this. Okay, so go back to EasyEDA, and now we basically just have to do the same thing for all the other holes. So again, I will place 4 of these. So let me place one here. We will make it 3.2 millimeters in diameter. Now this is a bit tricky. Okay, so the rightmost point on our panel is at 40 on the x-axis. So we have to subtract 7.5 from this. So 40 minus 7.5 is 32.5, I think. Boom. And then for the center on the y-axis, it's actually the same as this one. So it's 11.25. 11.25. Boom. So this one is okay as well. Oh wait, let me check if that's actually correct. Does it have to be, is it the same distance from the other side? Yeah, it looks symmetrical. It would be very strange if it was any different. And I think that's the way I did it for the filter too. Okay, so we have placed the ones on the top, which is nice. So they are in there. And then what we do is we replicate the whole thing for the bottom. So we have to do a bit more math. Let's select this one. Let's pump it up to 3.5 millimeters. For the x-axis is actually easy because it's just 7.5. Now the y-axis is a bit more tricky. The question is, what do we have down here? I think the lowest point should be minus 114.25. Oh, so it's actually, oh, that's convenient. So I think it's really just the value here with a minus sign and with 100 added to it, right? Yeah, that makes sense. So I think this should just be minus 100 and, what was it, 111.25? Is that correct? Let me check this one. Yeah, 111.25 and a minus sign. That should actually be it. Hope that works. Okay, let me place this one. blow that up too, to 3.5. On the x-axis, we have, again, 40 minus 7.5 with this, which is 32.5. And then here, minus 112, 11. No, 12? Fuck. 11. Is that correct? Like, this is something, if you mess this up, then and you send it out to production and it comes back and it just doesn't, it just like slightly doesn't fit. I think that's the most annoying thing. But yeah, the values seem to be okay. Okay, so let me check in with the chat, so just to see if you have any questions, if there's anything unclear. Let me scroll up. Let me scroll up. Okay, Roy says, somewhat related, if you keep the internal PCB 10 centimeters, it'll be cheaper to produce at JLC PCB. It makes it more efficient for them to produce, also better for the environment because they use less material. Yes, exactly. This is something that someone also said about my filter PCB, because it's taller than 10 centimeters, even though there's a bunch of empty space. So yeah, good tip, keep it to 10 centimeters. It's a good general rule. Paul asks, ambulance. Yes, it's a constant thing. And you can imagine when I am shooting my regular videos, it's really terrible because I do the voiceover separately, and I don't really have a different room to go in. And so if I record here, which is hard enough already, and then like every 5 minutes, like an ambulance drives by, it's super annoying. But yeah, that's what you have to deal with when you live in Berlin, I guess. Martin asks why 2 layers not needed. Yeah, probably could do 1 layer, I'm not sure. Could change that. Cursor is not visible. Yeah, this is a problem with the streaming software. Actually, someone, I think Peter sent me a tip on how to activate that. Didn't get around to doing that, so for now the cursor is just not visible. I'm sorry about that. Schreibmaschine says, on a PCB panel, it isn't doing any electrical work, so the backside of the panel isn't doing anything. If you're asking why the design has 2 layers instead of 1, it's because, no, Schreibmaschine, he was asking, like, when I created the panel, I selected 2 copper layers, which is not really necessary for a panel, I guess. CS80 is easy. Not sure what you mean, John. I'd have to rephrase that. Martin asks, is that hole under the socket really needed? Did not find it on PCBs I've ordered yet. I think it is. I can switch over to the view here. Let me get one of the sockets. I don't know. Where are they? I think here. Yes. So here's the socket. Here's the PCB. And we will need a cable. So here's a cable. So let's do the test. I will put the socket onto the PCB. Boom. And then we will put the cable into the socket. And then let's see. Oh, you're right. Actually, you can see that it does not seem to be going into the hole at all. So yeah, actually it's not coming out of the hole at all. So probably you're right. I don't know if there's other cables that maybe have a longer connector, but yeah, it appears not to really be necessary. That's curious. So I wonder why Thonk put that on their page there. But yeah, whatever. Also, maybe that's relevant. Like, these are the knockoffs. These are not the original ones from Thonk. These are like the tighter knockoffs. Maybe they are taller. Not sure. Let me quickly check if I have the real ones somewhere. So these are the fakes. Nope. We could maybe check it out on a real module. Give me a second. Okay, so this one I have built with the actual Thonk originals. So let's try this. Yeah, it's not even coming close to the hole. So I guess you're right. I think they're really not that necessary. Maybe anyone can clear up like why they put that in their documentation. It's a bit weird. But yeah, okay. Yeah, I will check the chat again. Buzz says it's not absolutely necessary, but it reduces the risk of the tip breaking the solder mask and shorting the copper fill over time. Yeah, but as we saw, it's not even coming out of the socket, so who knows? Top Quark says, I have real problems with the CAD tools not doing what I want. Yeah, I know that feeling. It's with all of them for me. I think there's just a bunch of stuff that is very unintuitive or very specific to the software. Like, for example, there's one strange thing that I think, who explained that? I think James Pearson explained that to me. So there is a thing, there is a difference between selecting things like this. Like if you draw a selection from left to right, it's interpreted differently from by the software in comparison to if you draw the selection from right to left. So if you draw it from left to right, you have to actually select the entire thing you want to select for it to be actually registering. And if you just select a part of it, as you can see here, I'm only selecting the left half, it doesn't register. But then if you select from right to left, you can just select like a little part and it selects the whole thing. So that's just one quirk that I've been told is kind of normal for these CAD tools, but yeah, that's just something you have to know, I guess. I don't know. Okay, Kuhn, I can't pronounce the name, sorry, says, when you check the X and Y positions for the alpha pod component, how do you know that the shaft and the hole line up? Does the shaft location on the potentiometer also matter? Not sure if my question is clear, sorry. I think I know what you mean. So I guess the question is, you select the location for the footprint, and then the question is, you set the coordinates for that, and how do you know that the shaft is actually in the middle of that? And the answer is, I'm actually not sure, but for this it worked, and so I just keep doing it like that. Not sure if that is a satisfactory answer, but in my experience it has worked. So just selecting the footprint, putting in the coordinates, and then just translating them to the panel has worked for me. Hope it will also work for you. So yeah, maybe that helps. Paul says, I mean slots on the rails, not holes. I have to scroll up and check your... you're saying there's a certain amount of X latitude in the rail holes. Yes, and normally, like I have the rec route, I think you can move these on the rail. Actually, you can move the holes, so there's a bunch of wiggle room actually. Paul says there'd be no reason to have the plugs go any further than the contact locks. Yeah, that's true. Buzz says, no, not all cables are made equal. Yeah, that's a good point. Maybe there actually are cables that have a longer jack. So yeah, probably still a good idea to have the hole there. Schreibmaschine says 2 important things. Some jacks are longer, and the hole is helpful in case the jack breaks off inside the socket. Probably valid points, yes. I had the tip of a cable break off inside the jack last week. A hole would have made it very easy to fix. That makes sense. James says, hi, yes, that selection is common to CAD and other drawing tools. Glad my explanation was helpful. Yeah, actually very glad that you explained it to me, because it's if you don't know, this is a complete mystery. So that's weird. Schreibmaschine says, when I said some jacks are longer, I meant some cables might have longer tips which can poke the PCB. That makes sense. Okay, hope I answered your questions. So let's get back into it. So we will jump into EasyEDA. And as we can see, we have now a nice looking little PCB. And I think we can already go into the 3D view, yes. And we can see that it is indeed working as expected. So we got our screw holes, we got our tuning potentiometer, and we got our 2 jack sockets. Cool. So from here, we have to do basically just 2 things, with the last thing being kind of a weird addition. So I'm going to save this for last. But for now, what I want to do is I want to do the design, basically. So I can quickly show you how I did this for the filter module. What I used is basically just the tracing tools and then text. And that's basically it. You have more options. So there's actually, I mean, this is not a tool that's made for designing anything, but you have some options here. And I guess the most powerful option would be this tool, which is for you to select an image to kind of print it onto your PCB. So if you're into that sort of thing, you could theoretically just go in here and you could just, select some image. And then what it will do is it will kind of make it into like a black and white thingy, and you have like some wiggle room here, so you can choose like how much it simplifies it. It's basically just a very basic filter tool, basically. And yeah, so you can do that. You can insert this and you can print it onto your PCB. And let's quickly check how this would look. Ooh, no, it's actually not that bad. But yeah, if you're into that sort of thing, you can just import your pictures and you can make them into a background. You could, of course, also just make an entire layout in Photoshop or whatever image processing tool you are familiar with, and you could just import it and you can then just print it on here. But for me, my problem is I am not that good with Photoshop or any image editing software for that matter, which is why I draw everything by hand, by the way. But yeah, that's why that was kind of off the table for me. And so what I went with was just making the design basically here in the tool. And the way that you can do that is you can of course, you can edit all of the layers of the PCB, right? So in the last episode, we saw that if you're on the top layer, on the bottom layer, and if you then select this tool, you can draw traces onto the layer, right? But right now, these would be actually like copper traces that are meant to connect different components on the PCB. Which, by the way, can also look cool. I don't know if we can already see this if we go into the, yeah. So here you can already see this. So the interesting part is now there is this copper trace basically underneath the solder masks. So it's underneath the colored part of the PCB basically. And so you see this kind of shining through. I saw people use this as a kind of like aesthetic device. I didn't do that, but it's definitely something that you can also do. It's a nice option. But what I did instead is I just went straight to the top silk layer, which is basically just the layer that, you know, these labels are printed onto. So the footprints and, you know, anything that you want to put onto the PCB is printed onto the silk layer, and anything you put on there will be visible in kind of whatever, like ink or I don't know what this is, on the PCB's face basically. And so that's what I decided to use here. So I just went to the top silk layer, and then I selected the tracking tool. And then what you can do is you can basically just draw in these weird shapes here onto the PCB. Now, if you want to get really fancy with it, you could also do stuff like, you know, drawing arrows, for example, like this. Oops. Doesn't look that bad, I think. Let's check this in the 3D view. Boom. So you can see there's a nice arrow on here. And of course, I mean, the tool is not meant to be used this way, but I kind of like it because it's like making something out of nothing, you know. So that's why I went with this approach. But okay, let's take this a bit more seriously. So, but before we kind of add like these visual flourishes, I think the first thing we should do is we should kind of label our connectors here. And to do that, we can use the text tool right here. And if you click on that, you can see that it already inserts or gives you a text to insert. And since I have already selected the top silk layer, we are on that top silk layer. You can identify this by the text being yellow, so you know that it's going to be printed on top of the PCB. So let's say I put this above this jack socket. Now you might notice that this font is a little bit ugly. I mean, maybe you like it. Maybe it's your style. For me, this looks very I don't know. It looks ugly. So what you can do is, if you dislike this, is you can go in here and you click on the fonts management button. And normally these two wouldn't be in there. So normally you would have just these three kind of factory fonts here, which are all not to my taste. And so what I decided to do is go on Google Fonts, which is a very nice tool. It has just a whole bunch of fonts that you can check out, and you can you can sort them also. By trending, for example, you can go to most popular, you can go to newest, and that way you can try to find something. And of course, it would make sense to put in to put a text in that we're actually going to use on the PCB in the end. So in our case, so right now we are trying to do the CV is probably not the best text. Okay, so let's try the tuning potentiometer. And then, like, if you're so inclined, you can go through all these fonts and look for something that appeals to you. In my experience, the problem is that the way it looks here is not necessarily going to translate to how it will look once you have printed it onto the PCB or even imported it into the software. So probably you will have to try a bunch of fonts to find some that you actually like. For me, what I did is I went with a font that is called Quicksand, and this one here. Now again, like if I actually look at this here, I don't like it all that much, and there was also my like when I initially like searched this out, I wasn't sure if this was going to look good, but in the end, when I then printed it onto the PCB, I actually liked it a lot. So here. It's fairly neutral. I think that's why I like it in the end. But yeah, so if we go back here, so what you could then do, or what you would have to do, is you would have to download the fonts package from the Google Fonts page, and then you basically just go in here and you look for the font file, which is this one. I unpacked it, so it's this one, and then you just click on open it, and it imports it, and then you can use it inside the editor. So actually I went with the light version, so Quicksand Light is what I went with. Okay, so if we select this one, oh no, actually we have to select it here. So we go in here and we say Quicksand Light, and boom, now it looks a bit nicer. Okay, so a couple notes here. Another big question is, if you are printing this stuff, or if you're having this printed by the PCB company, you have to be aware of some restrictions. So what they say, what JLC, PCB for example, actually say on their page is, I have to look this up now. I don't know if I actually remember what the restriction here was. JLC, PCB, silk screen, text, size. Oh yeah, here they say. They say. Let's look for text. Oh. Font. No. What was it? Drill hole solder. Is it solder mask? No, that's not correct. Board outlines, panelization. Okay, let me go back and check it here. Minimum text height. Okay, but here we can see it's 0.8 millimeters. And it says characters height less than 0.8 millimeters will be unidentifiable. And we can kind of see this if I switch over here again and you look at the text here. So I did the stylization where I just printed the name of the module multiple times going down there, and you can see that the smallest, iteration is already, it's still readable, but it's not perfect. But yeah, that's the limitation that you should keep in mind probably. So let's go back here. Let's go back into the editor and let's look at the size that we have. So we can see we are at 2 millimeters, which is way above the 0.8 millimeters, which should be the minimum size. So we're actually good here. But still, I think that this is like in comparison to how big the hole is, this is not big enough. So I would rather go with something like 2.5. Let's look at what I did here. So what I did here is 2.75 actually. And I think on the real thing this looks quite nice, so I guess I will go with the same thing. Of course you can go hog wild here. So you could make it huge, you can make it just way smaller, whatever. So let's change the text first. So I will just call this CV, and then I will try to place it properly. Now for the placement, I haven't really found a kind of foolproof way to properly like align this with the holes. If anyone has an idea here, feel free. So what I did before was just to try and align it by eye as much as possible, so we can see that this hole is basically like, it's just a little bit left to this line, a little bit on the left of this line is the center, and so I would probably pull the labeling also a bit to the left of that line, and then have it a fair bit above the hole, because the problem is that you are going to put a nut on top of this, right? And the nut is definitely going to be wider than the hole, and so you don't want to put the label down too far so that it will get covered up by the nut. So that's why I decided to put it, a fair bit above the hole, basically. Okay, so that's the CV part. Then let's go for the other label. So this one I would simply call out, and it already has remembered the parameters, which is great. But now we also need to kind of make this match up with our hole, and we can see that the hole is bordering on the line here on the right side, and then it's extending way beyond the line on this left side. And so I guess we should probably move this label a bit to the left. And to me, this seems to be okay. Maybe move it a bit here. Again, this is probably something that we can hash out in the 3D view at the end. And again, if someone has a tip on how to place these properly in the tool, then feel free to tell us. So I think it has to go a bit more to the right, otherwise it looks kind of off center. So let's move this thing a little bit to the right, like that. We go into the 3D view. I think it can still go a bit more to the right, right? Or maybe it's okay. We'll just leave it like that for now. Okay, and then the next thing that we will have to do is we will have to put in a label for our tuning potentiometer right here. So go up here, call this tune, and here it is actually a bit more tricky. Because the thing about potentiometers, of course, is that you are most likely not going to just leave it like this, right? This would be very awkward, turning this thing. You don't know where it's turned to. You have no indicator. It's also not very nice to grip this. So what you are most likely going to do is you are going to use a knob cap here. And I will have to look if I have one down here. Perfect. Okay, so here I have these nice silver knob caps, and since the tuning knob it's kind of important to have some precision there, I would use a big knob like this. Of course, this is down to personal preference again, but for me, I would use a knob like this. And now the problem is if we put our potentiometer in here and we put our knob on top of that, then you can already see that we need to make sure that the label is like far enough away from the hole to kind of allow for the knob cap to have the space it needs, basically. And so what I did here was just like, for practical reasons, I decided to put in this this circle to kind of show myself the area in which I shouldn't have placed the label. And in the end, I just ended up keeping them because I thought it looked kind of cool. And so that's how that came about. But let's jump back into the software here. Boom. And okay, so what we'll have to do here is we will have to first move this a bit up. And we will, or I will just do that now. I will just draw a circle. Whoops, that did not go well. Let's just draw it like this. And then what we can do is first we can select the same center. So 20 and minus 15. So if we select our circle again, we can say 20. Oh, I'm really close. 20 and minus 15. And then we need to talk about the radius. So 10 millimeters is probably going to be too much. But if we look at the packaging, and probably if you buy these knobs, you can probably just look this up online. But if you look at the packaging, we can see that it is supposed to be 6.4 millimeters wide. No, that's just the hole for the potentiometer. So it's obviously not 6.4 millimeters. So because I'm lazy, I'm just going to measure this. And don't make fun of me for my measuring method. This is actually the best option that I have right now. So we will just put this next to our measuring tape here, basically, and we can see that it is 20 millimeters. 20 millimeters in diameter. I don't know if you can see. I don't think you can see, but you can see like this, no? Like that, yeah. So it appears to be 20 millimeters in diameter. So if we go back into the software, we can say that we want this circle to be at least, what? No, that can't be right. Wait. No, it's not. I think it's not 20. It's not 20 millimeters, right? I think these are actually 2 centimeters. Oh yeah, of course, 20 millimeters. No, 20. Wait, 20 millimeters are. Okay, this is unraveling. Wait, let me put this back here. Let's put this down to 2 millimeters. No, it can't be 2. Also, it can't be 20. Can it be 20? It's the radius, of course. We have to put the radius at 10, and then we have a total diameter of 20, right? Okay, it's not, of course it's not 40. It's 20 in diameter. Okay, so radius is 10. Should have paid more attention in math class. Okay, but at 10 millimeters radius, we are. This is just basically barely containing the knob cap. And so what I did on the filter PCB is I made it a bit wider than the knob cap itself is. So let's go with maybe 12.5. Maybe that's even not enough. Let's try 15. Yeah, I think 15. 15 should be okay. So it's nice and prominent. Okay, and this now helps us to position our label here. So to keep it kind of consistent with what I have down here, I think I want to have the same distance. And yeah, you can see there's 1 square between the label and the hole. So I will do the same thing up here. I will keep a distance of 1 square, or roughly 1 square, between the text and the hole, basically. Okay, and now I'll try to center this as much as possible by eye again. I think it has to go a little bit more to the left. This is a very unscientific process. This looks okay to me. Let's check it in the 3D view. Oh, interesting. He hasn't updated the radius of the circle for some reason. That is very strange. Let me save it. And maybe this will update it. I'm not sure. No, I've had this problem before, actually, that he just didn't want to acknowledge that I changed the values on this circle, and this is very annoying. Let me save it again. Let me go into the 2D view, and here he also hasn't acknowledged it. Does anyone know why it's doing this? Is it just a bug? Maybe it's just a bug. I'm not sure. I think if I move it, if I do this and then I can't do that. So I think I have to move it, and then I have to reset the coordinates through here. So I have to go to 20 and then minus 15 and then save it. No. I'll just save it in here. Thank you. And then go here. Yes. Now it's updated. I don't know why it does this. This is very annoying, but apparently it just does this. So, yeah. Okay. So one thing I feel tempted to do, like when I inserted this picture, I think I actually liked the way it looked on the PCB itself. So maybe let's play around with this and see how this would look with the labels and everything. don't see this doing that much. I think I like this. Let's try to get it up to 100 millimeters. It will be a bit pixelated, maybe, but no, we need to get it even bigger, right? We need to get it even bigger to fill out the whole PCB. Probably it won't look good because it's not covering the. It's covering. Oh yeah, it's covering the actual labels. Maybe if I move it down to the top layer, right? So now it should be on the. It should be on the actual copper layer. This might look nice. I don't know. Ooh. Yeah, why not? But I have to redo it and make it bigger. Let me select that again. Boom. We'll adjust the parameters again. Actually, I have no idea what I'm doing here. Just trying to make it look okay. And we have to do 128.5, right? So that it matches with the PCB. And we are again on the circle layer, but that's actually not that bad. Let's move it here. Let's move this to the top layer and let's check it out. No, he still has it on the top circle layer for whatever reason. Oof, this is really slowing the software down. Oh, this doesn't feel all that responsive, to be honest. Maybe it's a good time to check the chat. Okay, Martin asks, is EasyEDA limited to JLC PCB or can it export fully? It can export fully to a Gerber file and I think other formats, so it's not that limited in that regard. Buzz says, using circles in the document layer with the size of knobs, mounting nuts, etc. is a useful method to make sure text and graphics work in the layout. Yep. Peter says, in KiCad you would center the text over the hole and use move exactly to move it up to the desired location. Yeah, maybe there's an equivalent here in EasyEDA, but I haven't found it yet. But good tip. Paul says, you can certainly give them the same Y values with an alignment tool. I will check for that. Okay, Kern says, is there a way to print a PCB from a PDF or SVG exported from Adobe Illustrator or Affinity Designer, for instance? Don't know that. Someone else will have to answer this question. I'm sorry. Okay, Roy says, general alignment rule for type, use your eyes. The way we perceive round shapes and pointy ones is very different, and so you better trust your eye and not a perfect mathematical calculation. Try placing a circle next to a triangle, both same height, and you'll see what I mean. Yeah, that's actually true. So probably for the label placement, it's actually smart to just kind of hone it until you think it looks good, and then it will look good, hopefully. Israel says, what are those pots you have? They are alpha 9mm pots, they're called. You can find them on Thonk and in other pages. Paul says, radius is half. Yes, I figured that out. Thank you. Kern says, that's good to know. I was very precise with the measurements in Infinity Designer, but that's just a waste of time then. Maybe, yeah. Rory says, what you can try to do is design Illustrator and export it 4 times larger, then scale it down and pray to the PCB gods it will work. I haven't tried it yet, but going in TH coming month. Okay. Martin says, needs more space above the socket because of the nut. You think so? I will try to push it a bit up then. Maybe it is possible to import the panel design as an image and then use it to align the holes in text. Yeah, that would be probably my idea to try and do. Paul says, are there no Z layers for text image? The top solder mask, I think, would be the closest equivalent to that. Paul says apparently not. Or well, maybe you just have to put all text on after. Not sure what you mean. What do you think of EasyEDA compared to Altium Designer? I have only used EasyEDA. I'm not too fond of it because it has a lot of bugs and quirks. So I think probably there are better tools out there. Peter says this is why Photoshop and Co don't run in the browser. Yes. I mean, of course, like I am asking it here to import an image and then put it onto the PCB and render all this stuff. So probably understandable that it's slow. Okay, so let's check this. And it's still putting it on the top layer. Okay. Probably it's really just over challenged with this, so I will just delete this. Oh yeah, my laptop is really getting hot. Okay, so let's just drop this out then. And yeah, Martin said move these up a bit. I'm inclined to agree, so I will just put them here. And then we are on the safe side, I guess. And I want to get them aligned on the y-axis too. So this should probably work, maybe a bit, no, it's fine. And this one is, yeah, I think this is okay. Let's go into the 3D view again. Yeah, this looks okay to me. Okay. And now you will probably notice that this is still a bit boring. So the first thing that I will do is I will do the logo thing that I've done before. So I will basically just take the text tool. I will take the module name, which will be basic shapes, because I don't have a better idea right now. And I will try to place it in the middle between the two mounting screws. So I'm guessing somewhere there. And then what I do is I simply take this, copy it, I paste it, and then I put it just underneath the other one. And then what I do is I go down on the font height. So we are now at 2.75, and now I'll go down to 2.25 maybe, and see how that looks. I think that is fine, but I have to realign it. So what I try to do is I kind of try to align like the first letter with the end of the first letter of the bigger iteration, basically. So the B here, the start of the B is lined up with the end of the B here. And then if we take this one, we copy paste it, we put it down here, boom. And again, we do the same trick with reducing the font height. So now we're going down to 1.75. Again, we align this thing. We try to get the text. Maybe we want to get this a bit closer. I think this looks nicer, and then get this closer as well. Like that. Again, copy it, paste it, put it down here. Reduce the size to 1.25 millimeters. And let's do it again. And now we would be at, I don't know, now we'd be just right below the readability threshold. So yeah, I don't know if it's smart to put it here still. Let's see how it looks as a big picture. Yeah. I mean, this is all just a taste thing, right? So your mileage may vary, and of course, you probably have other better ideas. I think I want to move them all a bit more to the right so that it looks more like, it's kind of disappearing into the panel. So what I will do is I will select another point to kind of align them with. So I will try to align them maybe with the start of the A, because then now you can see that the B is starting where the A is starting, and the S is ending where the E is ending. So if we can keep this up, this might look nice. Let's move this as well. I think we have to move it a bit more there, and then move this one even further. Guess here, and then move this one. Yeah, this is now basically between the S, the middle of the S and the middle of the P. I have a feeling that's a bit too far to the right now, it looks. Let's check it here. And yeah, you can see that it's kind of skewed to the right. I mean, it doesn't look so bad, but I would like to try to have it kind of centered. Sorry if this is boring, but to me these things really matter actually. So move this here, move this guy a bit here, boom. Okay, let's check this again. Yeah, I would say good enough for now. So, and because I am a vein, I will also put my name in here, but I usually do this in a smaller font, not the smallest one, but I think I will go for 1.75 maybe. Oh yeah, one important thing also, like I really feel like for these kind of labels, like all caps looks the best. I've tried it with a lowercase, but to me that just looks horrible. So again, something you will probably have to figure out yourself, but yeah, for me that's how it is. I don't like that placement. I don't like that size. Let's go a bit smaller. I don't like to have it in the center because I'm not that vain. Let's try to have it line up with this guy. I think this could look quite nice, and then also have it line up on top of the screw basically. So like this maybe. Let's check it out. Whoops. Boom. Nah, don't like it. Let's go back in here. Let's maybe move it here. I think this could look better. Boom. Go into the 3D view. Yes, I think I like this more. Yeah, it's gonna do. It's gonna do for now. Okay. So now that that is done, basically we have all the kind of functional aspects. And what I would like to do now is I would like to get a bit fancy with the flourish basically. And so I don't know, like my process here is not very it's not very, how would you call it, it's not very pre-planned. So I don't really do well like when I draw or when I do like any kind of design work where I have like a big concept of what I'm going to do. Like usually I just start doing something, and then if it looks good I keep it. If it doesn't look good then I throw it out. So what I will try to do is I will go here with the track tool. I'll reduce the routing width a bit. Oh no, 0.2 I think was the, yeah. And then what I will do is I will try to make something that looks nice to my eyes. And yeah, this is something that I also like to do, is like drawing over the holes, because I mean, of course they're not printing onto holes because you can't do that physically, but you know, the line will basically just go through the holes basically, and it will come out on the other side. It will look quite nice. So okay, and what I also like to do is I like to make these lines kind of line up, you know, on the vertical axis, because you can see the starting point here is here on this height, and the ending point is on the same height. So theoretically, if you had multiple of these, then they would line up nicely, and the line would be meeting up with the next module, which I think is a nice touch. And as you can see, this looks like, to me, this looks quite cool actually, because it's very random, but it's also like it has a pattern to it because of the way that the tool works, because it enforces like a certain direction in the line. So that's what you can get with this, and I really enjoy this. Maybe we could even try, like, this is something that I haven't tried before, which I'm just seeing, is what if we took this, what if we copy pasted this, and what if we just put it right underneath the original one? How would that look? I think this might actually look quite cool. Or maybe not. Let's see. Maybe move it down a little bit. Maybe move it down a little bit. So if we take this, no, this again. This is my worst enemy. Like, for some reason, if you, like, you can't really move this. Maybe I can move it here. I can just move the individual points. Ugh, this is super annoying. Okay, so I will have to copy paste it again, basically. Good to know. Move it that far down, and they don't touch. Let's try this for now. Maybe let's do 3 of them. And let's try to make it as similar as possible. Boom. Okay, let's go into the 3D view. Let's check this. Not too shabby. Okay, so they are meeting up here, so that's what I need to keep an eye out for, but it's actually not that bad. It's not that bad. So let's kick these out again, and let's focus on the part where they are actually matching up, which is back there. Okay, so let's just go with enough distance. I think this should be enough distance. Boom. Let's check this. Yeah. Why not? Why not? But maybe actually I did like it more when they did kind of match up. No, actually I preferred it when they did touch. So let's try this again. And yeah, I will finish it quickly. I won't bore you anymore with this. Put this here. We'll put one above this. I guess this should be okay, right? Boom. Let's try this. Yeah, why not? Why not? Why not? Yeah, whatever. Okay, so we have this kind of flourish down here. And then we will go over here. I will save this. And we have a lot of real estate here that we need to kind of cover with something. Why can't I zoom? Can't zoom anymore with my mouse pad. So there's a lot of space here that we should probably kind of cover. Maybe since it's just a sawtooth oscillator, maybe we could do something with a kind of sawtooth thing. Not sure if that will look good. Let's just try it. So I will start here. I will move there, like this maybe. Boom. Move straight up. Move straight down. Maybe this is a bit tacky, I'm not sure. Let's see how it pans out. Boom. Oops. I think this will be... maybe if I do the same doubling trick, I'm not sure. I think this is just not good. It's just not a good idea. But yeah, I mean... what do they say? Like, you can't make an omelette without cracking a few eggs. So, put this in there. Copy it again. Put it in there. Oh, whoops. This actually didn't. Put it in here. Okay, so just make it line up with the boxes. I think that's like the easiest thing here to do. Because usually, like, if something is regular, it looks nicer, in my experience. So maybe this I can save this kind of crap design. You know what? I don't really like it. Maybe one thing that could save it is just simply moving it also a bit to the right. So moving it up one kind of square, and then moving it to the right also a little bit. Let's see how that looks. Go in here. I'm gonna pass on that. I don't like that. So boom. Maybe if it's more intricate, that could actually fix it. But for now, these are not good. Be gone. Ah, yeah, from right to left selecting, right? Boom. Perfect. Or maybe we just keep it like this for now. Let's switch it over to white and let's see how it looks. Nah, it's too empty. It's too damn empty. So there has to be something. There has to be something here. So maybe if I just go a bit, maybe if I just go a bit more crazy with this. So let's simply do this and then give it like some weird, like changing shape. It's not true to what the oscillator does, but who cares? Boom. Let's go up here. Let's go over here. Let's move it there. I hope this is interesting for you guys. Just seeing me clicking around here. I don't know, for me it's very fun. Maybe it's boring for you, but yeah, I don't care. Let's just see how this pans out. Yeah. Okay, and then again end on the same height. And then we will just simply take this and we will just do the same idea because it worked once, and so why shouldn't it work again? I think it won't work again because the design is terrible. But maybe I'm wrong. I'm usually wrong about these things. Like at first I always think, oh god, this is absolutely horrible. And then once I follow through with the idea, it actually doesn't look so bad in the end. Hopefully that's true here as well. I don't know, this is too much. Maybe this is too much. Okay, let's check it out here. It's not bad. It's just a bit random, I fear. Okay, you know what? Maybe I have a better idea. Maybe what we will do is to just not overload it with different kind of geometrical ideas. We'll just take all of these and we'll delete these, and what we'll do instead is we will simply just reuse these guys. So just copy paste them in here, and then we will call it a day because I feel like I'm obsessing about this too much, I'm afraid. Okay, so let's move this. This is what I did here. Yeah, roughly. Okay, and then maybe go with multiple. Go with maybe. Not all that happy with this. But yeah, we can just try to go with multiple iterations of this. So boom, Boom. How many did I have? 1, 2, 3, 4, 5. Here I had 3. So maybe we should just make it ascending. So 4, 5, 6. Nah. No. That is super random. That is super fucking random. So we'll kick these out. Maybe if I just keep the top ones. Maybe if we move it to white, does it change anything? It just looks like random, you know, like notes in a notebook, like sheet music. I mean, it looks terrible. Okay, so this is a failed experiment. So yeah, what I will do now is I will simply leave it be. We will delete this, and we will simply call it a day for this stuff. And then I will have to show you one final thing that I had to do to make this panel work for JLC PCB. Okay, let's switch over here. Let's check this out again. White. Yeah, well, maybe minimalist is also okay. Okay, let me check the chat for a second. Peter says you are on the silk layer, which is not 100% accurate at all. You mean for placing the labels? Broccoli says there's not a tool that will exactly align text to center. Maybe there is, but we had the discussion that this is probably not the best idea, because in the end it's all about taste, and if it looks right to you, then it's right. And the mathematical precise position might not always be the one that looks the best. Peter says, seems this is not my party, so much time on design stuff. Well, one could run a patch already. Yeah, sorry about that. Roy says, Peter, do you know why there's a difference in accuracy between the different layers? I would like to know too. Peter says, I know the track layers and holes and stuff are accurate as hell, while the silk layer is not. Basically, it seems to be a question of the resolution of the layer and offset printing. Yeah, that is probably correct. Let's check if there are actual questions here. Boop says the tools at the center top below help looks like they would do centering. Probably select multiple elements. Will then center based on the position of the biggest element. I'm just guessing. I will go into the tool and I will just quickly check this. The one below help. So I think you mean this one. This is labeled align horizontal centers. And probably this could be what we're looking for, right? So if I select the whole, I select this one, and I select the centering tool. Oh yeah, you're right. Perfect. This is very good. Let's do this as well for these guys. Boom. No. No. We don't want to center it like this. We want to center it horizontally. Boom. Oh, this would have saved me so much time when I was doing the filter. Okay, that works. And yes, perfect tip. Nice. Good work. Roy says, I find it so annoying that there is a difference. Silk screen can be quite an accurate process in general, but it seems that it's not a priority in PCB production. Yeah, probably. This is, I think someone else remarked this too, that they, I think they put it on by hand. This is what someone said. I'm not sure if this is true, but apparently it's like you said, it's not a priority because, I mean, in general, the idea here is basically that you have labels and that you have the orientation to put in your components. I don't think that their major concern here is design. So we are kind of abusing the system here. So we can't expect to be treated well. I promise to help you with the design. Thank you. Peter says, of course, it's not. The technical accuracy is needed, not the design fluff. True. Limit to 5 lines to remind you of musical stuff. Yeah, that's what I wanted to avoid, I think, because it's a bit cheesy. Peter says, I find these repeating basic shapes much more ugly than the line stuff. Okay, I like it. Roy says, yep, very frustrating though when engineers work with designers, magic happens. Yes. Is the stream quiet for anyone else? I know he's speaking softly, but it's pretty low volume still. Actually, I tried to slap on a compressor onto my voice. I don't know if it's helping. I can try to put it up in the future. Okay. So let me jump back to the design tool. So now we have this thing here. One thing that we need to do is, if we want to now go ahead and have this manufactured, we actually have to trick the manufacturer a bit, because I will show you, if I now go ahead and I try to export this as a Gerber file, which is the G with a folder here, then it will prompt you to do the DRC check, which you actually don't need to do because this is a panel. This is not a proper PCB. So we can say no, just generate the Gerber file. And I'm irritated because it's cutting off the text here, but I think it's maybe just a quirk of this preview. And as you can see, this tool is directly linked to JLC PCB, so they offer to just order this for you, but we're going to say no. We want to generate the file, and then we get this zip file here, which we can then use. If we go over to JLC, we can hopefully we can log in. Yes. So what we'll do is we will say we want to order, and we can add our zip file here that we just downloaded. So if I go in here, we should be able to find the file somewhere, hopefully. Let me check where it put it. Oh, in downloads. Oh, it's okay. Okay, that's the name. That makes sense. So I have to look for G in here. Oh, no, I have to go to the downloads, and then I have to look for G. So, where is it? This is all something else. PCB. It should be called panel, right? There it is. Perfect. Okay, open this. Then it uploads it. And then what the page does, is that it shows you a preview of what the manufactured PCB is going to look like. And for that to render, you have to click on the Gerber viewer thing here. And, oh, interesting. Analysis results. So the last time that I did this, I actually had a problem here because it was not showing me the holes. It was also, I think it was not showing me the text on the silk screen. Ah, now it's bugging out again. Okay, let me check the color here. So you can see there's something funky going on. So it's actually not really working. I think I remember this was the problem last time too. And I know that this JLC PCB viewer is kind of notorious for being buggy, but what I did the last time to kind of trick it into properly working is that I went back into EasyEDA, and to have a reference, we can check the this one here, the panel that I did for my filter. What I did is I added an additional thing. I don't know if you can. This is the copper layer. I think this is it. No, that's the board outline. This is it. I think this is just a copper area that I added. Yeah, I think what I did is I just went in here and selected this tool here. I think it's called solid area. No, rect. Solid region, right? I went to the bottom layer, and what I did is I basically just, oops, again it won't zoom. I just drew a shape around the outline of the board, basically. Whoops, of course it triggered there. Okay, let me just do it like this. It's not, I think it's not important to be like super accurate here. So boom, 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 boom. Then we go back to the top layer. And then we go back to the 3D view just to make sure that we can still read everything. Cool. And then I will save this. Of course, I'm drawing something by accident. I'm sorry. Let us export this again. And I think the last time this kind of prompted the JLC PCB Gerber viewer to actually work properly. And I'm not sure if that actually does anything for the production process, but yeah, that's just what I did. Boom. Upload that. And then let's see what we get. Oh yes, now we at least get the preview here, even though you can see there's something wrong with that too, so it doesn't render properly. And again, the colors don't work for whatever reason. Oh, but white works. Okay, so this is how I would order it in the end. Let's quickly check the analysis results here. Okay, so before we had like a weird error message saying that you could not identify a layer or something. But to me, this seems like it might work, or at least the last time with the filter module, it worked like this. So yeah, I guess this should probably work. And I also just added this in because I read some horror stories of people who said that they ordered the panels and they just got them like without a silk layer, basically. Like they didn't get any printing on the board. They just got a board with the holes and the correct dimensions, but there was nothing on the actual silk layer. So that's why I added this solid region. But I'm still worried because it doesn't show. Like normally on this side, on the left side, it would show the preview of the front side. And it's not doing that, which is worrisome. Let me check the chat if someone has an idea here. Just use the 3D viewer. Let us try to use the 3D viewer then. Let's go in here. Let's go into the 3D viewer. I mean, if it's the same from EasyEDA, then it should work, right? But let's see. Painfully slow. Oh, look. Did you see that? Here in the bottom left corner, it says it's waiting for TikTok.com. Analytics.tiktok.com. So actually, the Chinese are spying on us on a big scale. That's interesting. Yeah, it doesn't seem to want to work. And I don't want them to send my data to TikTok. Let's just skip that. Okay, so you did it. Yeah, but essentially this is how I did it for the filter module, and this is how it worked. So I'm quite confident that this would work too. And then of course what you could do is you could select a color here, and cool thing about the silk screen layer is that it will kind of adapt to what base color you choose. So if you choose white, the silk screen layer will be black. If you choose black, it will be white, and so on. And then you have a bunch more options, but I guess these are like you have to figure these out yourself. Probably you only need one layer for this. And you know, for the thickness in the beginning, we established that 1.6 millimeters is actually fine. Like for me, it worked well. So it was okay. And oh, you can see that he says that, or the tool says that very few people choose this specification set, and that's why it's actually gotten more expensive. So now it's 23 euros for 5 PCBs. Oh, you can choose aluminum now. Interesting. I don't think they had this before. Okay. But yeah, this is something that you probably have to hash out yourself. So there's a bunch of more options that you can select, and then in the end you just order it. It's really dirt cheap, and you get it sent to you, and it's working fine. Still, I said this last time, I think in the future, like for my filter, I ordered these from JLC, but I think in the future I would kind of prefer to use a company that's not Chinese. I mean, we just saw that they are not very discreet with our data, so I think it would be a better choice to go with a different company. I think here in Germany we have a company called Eisler, and they are essentially like comparable in price. And I think I'm going to order there in the future. But yeah, that's on a different what's the word? On a different page. Okay, so for me, this would be it. So with the process that I just showed you, you should be able to make a panel like this one. And if you take into consideration the information I gave you last time, you should be able to make a main circuit PCB basically, and then you should be able to slot them together and you have your own Eurorack module. And that's all I know about that. And now would be the chance for you to ask questions if there's anything that was unclear, something that I should highlight again. Let me know. I will check and see if there are more questions. So Lucas says, could you elaborate on the pricing? Is the engineering fee for every single board in my order, or do I need to pay it once? That is a good question. Let us go back into this. But as far as I can remember, this engineering fee is just a one-time thing. It's not for every board. So let me check back in here again. We can just check on the order details on this one. Yeah, so here you can see for the panel and for the board, it was $8 in total. And you can see here the engineering fee was $4. Then, oh yeah, you can choose to have them remove the order number. This is probably important because normally they will put the order number onto the PCB. Now for the main circuit PCB, this is probably not that big of a deal because it's inside your case anyway, you won't see it. But for the panel, you should really, I mean, you have two options. You can either remove it here for an additional fee of $150. Again, that is not per board, that is for all 5 boards together. Or you can, I think you can somehow tell them where they should print the order number. So you could have them printed on the back of the front plate. That is free as well. You don't have to pay for that extra. But in my order here, I just decided to have it removed for $150. Yeah, so that's what that is. I mean, generally, like the lion's share of the cost is going to be the shipping, right? So you can see up here that I paid $57 in total for these 5 modules, which in itself, I mean, it's still super cheap, but you can see that the lion's share is shipping and taxes stuff. So that's how that works. Okay, more questions. This is why there is script save and co. I should look into that, I guess. Rabbit's guy asks, I was going to ask about a non-Chinese company. Yes, let me go back into the browser and I will show you this company. I don't know if you are in Europe or in the US. I guess if you're in the US, then this is not a useful option because, shipping to the US from Germany is probably also really expensive. But, okay, this page is also not loading. It seems like my connection is really bad today. I hope that the stream is not that affected by this. Or maybe their page is just down, but I don't think so. Oh no, there it is. Okay. Yeah, so here you can see, in general, it's like very similar to JLC. So we can also go in here. We can select our panel. We can upload this. And then let's see what they show us for the preview. Okay, so that looks actually much better. So they have imported the file correctly, and here we can also configure this the way we want to. We can see it is like making the boards themselves is more expensive. So we can see if we do just the beautiful boards option, then we can see it's 12 €48, and then tax comes on top of that, so we're at 14 for 3 boards. Of course, that's more expensive than JLC, but then again, I mean, for me, I am in Germany, so there are not going to be any taxes basically, and there are also, like, the shipping is also not that expensive. So I think in the end, it kind of evens out to the same price that I would pay at JLC. So for me, it is a valid kind of option in that regard. Okay, more questions. Peter says, Eisler a little bit more expensive as far as I remember. Well, as you could see, I think it's in the same ballpark with shipping and everything. So Lucas says, wow, that's dirt cheap. Yeah, it's insanely cheap actually. T-Killer says, just add JLC on the board where you want to place the order number. Yes, that's the way that worked. So yeah, you should do that on the back of the panel probably if you want to have it put there. Kern says, I noticed that ordering a higher quantity was remarkably cheap. Yes, obviously, like the more you're gonna order, the cheaper it's gonna get, obviously. Rabbit says, yep, USA, sorry. Probably just Google for a company in the US. Maybe there is something. I'm not informed on that. I'm sorry, but I would guess that there is a company that does that there too. Okay, especially for smaller PCBs like breadboard friends, for instance. Okay. Buck, what's going on? We are making panels, or we are done making panels. Peter says, when I checked 2 years ago, it was much more different. This makes Eisler a viable option for Germans again. Yes, there is one thing that you need to look out for. So maybe you can see this, I'm not sure. So here on my filter PCB, you can see that for the pots, the footprint here has elliptical holes for these things on the side. So these are for, these little grippy things that kind of make the pot stay in place or give it some additional stability. So they slot into these elliptical holes. But Eisler will charge you an extra fee, and it will take way longer to manufacture if you use this kind of footprint. So what you would have to do there is you have to use a footprint that has actually round holes, that doesn't have like these elliptical holes. That's something to keep in mind there. Okay, OSH Park is from USA, I think. Let's just check this real quick. So OSH Park, low cost prototype PCB. Oh no, that's PCB way. They tricked me. Here. About us. Yeah, made in the USA. Okay, but then the question is, how expensive are they? Let's quickly check this also. Yes. Oh, I actually like the color. I think this looks quite nice. Cool. We detected a 2-layer board. 3 boards will cost $39.95. Ooh, that's kind of steep, actually. That is kind of steep. Yeah, so if that is the price, then you probably have to contend with that or find something else. But maybe with shipping, this is still at the same level as JLC. Not sure. You have to hash that out yourself, I guess. Okay. So Pepeu says, sorry, late to the show. What are the best, cheapest options for us US peeps in the EU? For us peeps in the EU. Yeah, we just checked this out. So what I can recommend as perfect thanks, I figured the cost would be more. Yeah, happy to help there. Yes, the stream died. I'm sorry. But yeah, I guess, I mean, we're done anyway. So I hope this has been helpful. I hope you know how to make a panel now. If you have any more questions, feel free to either put a comment somewhere on YouTube or come onto my Discord. You can find the link to the Discord on my Patreon. And also, these streams are only available as replay on my Patreon. Because I kind of figured that I have to have more Patreon exclusive content. That's why I decided to make these replays Patreon only. So if you want to watch any of these streams again, you would have to support me there if you're so inclined. Okay, so if there are no other questions, then I'm going to end the stream here. One more note on the upcoming VCA video. So I know it's been a long time since I uploaded the last time. Problem is that this topic is really complex, and I kind of underestimated like how difficult it's going to be to explain this. But the good thing is, or the good news is that I have the kind of, I have a big chunk of what's going to be like a kind of very in-depth, like thorough explanation of how transistors, like BJTs, bipolar junction transistors, work. And I'm very happy about that, because it has been a mystery for me for the longest time. But now I finally feel like I have like a grasp on it, and so that video is going to be like rather long and rather kind of in depth. And in the end, we will have a very nice little classic transistor-based VCA. So I hope that you are stoked for that or interested in that. We will see. I'm aiming for the Monday after this Monday for that video to go up. I think I can keep that deadline. So yeah, that's it from me. Hope you got something out of this, and I will see you soon, guys. Bye bye.